You're listening to the N2K Space Network.
Welcome to T- Deep Space from N2K Networks. I'm Maria Varmazis, host of the T- Space Daily podcast. Deep Space includes extended interviews and bonus content for a deeper look into some of the topics that we cover on our daily program. And we talk a lot on this program about technologies of the future. But what does that really look like? So let's learn about Lockheed Martin's vision for the future of space with Dr. Nelson Pedreiro and the Space 2050 vision. Now, Space 2050 invites discussion about the future of space in 5 areas: a smart world enabled by ubiquitous communications, extraplanetary operations, space logistics, mission operations command utilizing artificial intelligence and machine learning, and space defense to strengthen 21st century security. It's the main topic for the Ascend conference in Las Vegas from October 23rd through 25th. T- will be there to share all the excitement with you.
My name is Nelson Pedreiro, and I'm the chief engineer for Lockheed Martin Space. This is actually a new assignment for me. I'm just transitioning from my prior role as the vice president for the Lockheed Martin Space Advanced Technology Center, which is really the innovation labs for space.
Well, congratulations. There's so much I could ask you about today, but we're going to stick to the topic of Space 2050 for today. Could you just give me sort of the pitch on what Space 2050 is, please?
So this actually started about a couple of years ago in my prior role leading the Advanced Technology Center for Lockheed Martin Space, right? The innovation labs for space. And in that organization, we have 2 primary roles. One is envisioning the future and determining what kind of capabilities and technology will enable that future so that our customer missions can be properly executed. The other piece is prioritizing these capabilities and technologies and then going and develop those, making sure that we can implement that vision, right? So these are the 2 things. So Space 2050 is really an initiative that I kicked off about 2 years ago, as I mentioned, to envision the future, identify and prioritize capabilities, and then start developing those. The 2050 mark is somewhat arbitrary, but it's not totally arbitrary. There is some thought that went into that. I really did not want it to be too far out like the 2100 or further out, because it then becomes more of a science fiction exercise. But I wanted it far enough out. So this is, when we started about 28 years out or so, that there is enough time for us to really develop remarkable, novel, disruptive capabilities. So that was a balance there that we selected that. And so this is what it is in a nutshell.
Excellent. Well, thank you. You anticipated my question about why 2050 very well. So yeah, if you could talk me through some of the high-level bullet points and maybe any future space missions that might support that capability, that would be great.
So on this initiative, what I challenge our team to do, it's really to envision space at large, the broad space ecosystem. And frankly, it was interesting because as we started, myself included, we were all thinking about this, what are we going to do in space, right? On the moon, on Mars, in cislunar, in low Earth orbit, and so on. But then I paused and I said, hey, how do we get to space? Access. We've seen over the past few years significantly decreasing launch costs, right? What else do we think is going to happen in this kind of time frame? But even beyond that, what's happening on Earth? Because what we do in space, the systems are designed, they're built today, they're all done on Earth, the workforce and so on. So we really took a step back and spent at least a little bit of time thinking about what's happening on Earth, how do we get access to space, and then, of course, we're all passionate about space. We spend the majority of time thinking about space. Now, in terms of missions, we cast a very broad net. At Lockheed, over the years, our portfolio is very broad, but every mission falls in one of these 3 categories, right? To protect, to connect, and to explore. And frankly, when you think more broadly about the aerospace industry, aerospace community, if you will, beyond Lockheed and so on, most of the missions we do, they fall onto those three categories. So this is what we've been doing over the past several decades. And this is what we foresee doing in the future. So when we talk about which missions, it's really a broad set of missions. It's remote sensing, where you have assets in space looking down on Earth for various different reasons. It's really communications, right? Communication satellites, communication to the public, broadband communication, protected communication to the military. It's really, broad at large. Communicating as we establish a presence on the moon, Mars, and beyond. So communicating into deep space, into moon and Mars, this is lunar, and then exploring. Actually, the timing for this conversation is great, right? Because just recently we had OSIRIS-REx bring back the capsule. And we're all, eager to see what the scientists are going to find on those samples there. So explore, and actually, not so recent as OREX, but it looks like every day we have some new discovery from James Webb Space Telescope, right? So my team, in my prior role that I'm just transitioning out, actually built a near-infrared camera, which is one of the primary scientific instruments on James Webb that provided those remarkable images that help us learn so much about our origins in the universe and so on. So it's really a broad cast. I could pick one, and if you'd like to do that, I can definitely do that. I could pick one or two mission areas and delve a little bit deeper in terms of the technologies and so on, but really broad and including the defense aspect of that.
If you could talk a little bit about one or two mission areas, I would be fascinated to hear more.
Let me start then with what we think is going to be happening on Earth that is relevant to the space community and future space missions. So in this kind of time frame, if we're talking 2050, right, it's far enough that we really think we're going to be seeing, and we're going to drive, we're not just going to be seeing, we're going to drive a whole new level of integration in design and analysis tools. If you look back the past 25 years or so, people who work in the field, they all realize how far along we've come in terms of design and analysis tools for space systems. What we're seeing is another quantum leap in terms of those advancements, to the point where the space professionals, folks like me and around the industry, we're really going to be able to play a different role, where we're going to focus much more in terms of what are the missions, what are the objectives, what do we want to achieve, and a lot of the process of designing, analyzing, and even prototyping is going to be automated. So that's on the design front. Today, we are already seeing mass production of satellites. You look at OneWeb, you look at SpaceX. Actually, Lockheed was, in the years past when we did the Iridium, 70 satellites or so, we were kind of pioneered that. Today, we're actually at a different level, mass producing that. And that's fantastic. We see that continuing and accelerating. What we're missing today that we believe we're going to have in this kind of time frame, 2050, is automating the development and prototyping, right? Development and prototyping today, it's still very human intensive, very laborious. It's not highly automated. We believe we're going to be able to do that through the automation of design and analysis tools and through the automation of manufacturing and so on, but in a manner that's tailored. So think about printing a satellite. Think about no-harness spacecraft integration. When you do things like this, what's exciting about it is that we're now, the speed of innovation is only limited by the speed of ideas. And we also are going to totally change the whole balance between recurring and non-recurring costs, right? So think about a production line of spacecraft, similar to what we have production line for automotive today, but that not all spacecraft need to be the same, because you're inserting new technology and you're tailoring them to the mission. And now if you're producing and developing, if you're developing fast and you're producing on a cadence, now you need to get these assets to space. And so let me talk a little bit about access, and then I'll talk about the missions in space. So in terms of access, we've seen a tremendous reduction in cost on that. We see that continuing, and I think that's fantastic. But when we talk about 2050, that's time enough that we should also be exploring different ways to get to space. Think about spin launch. Think about a space elevator, right? So I'm trying to be provocative here. But really, when you think about
Space elevator.
Yes, absolutely.
I mean, I'm a fan of that idea, but man, yeah.
Right, exactly. Yeah. So when you think about a space elevator, right, I'm trying to be a little provocative here, but when you think about it, it's not a new concept. It does not violate any laws of physics. It is a really, really hard engineering problem. But if we have shown over the years that when we put our mind, as a community, as an airspace community, when we put our minds to it, and there is the will, we can make things happen. Now, why is that interesting? Because it's not only a matter of cost, because it would be costly to develop such a system. But once it's developed, now you have continuous access to space. But it's also a very different kind of access, right? Because you eliminated the launch loads. And when you go look at the systems that we develop today, a lot of the design features that we have to put on, like think about James Webb, this very 6.5 meter segmented, pristine optical system with exquisite instruments, right? Optical instruments. And you put that on a launch vehicle and you shake that and you launch it, right? And
Yeah.
so a lot
Yes.
of the design challenges are associated with just the launch environment. But then when it's in space, it's a more benign environment from that perspective. So if we can get something like a space elevator to work, it also totally changes how you design systems and things like that. So we're talking about, not qualitative change. Hey, I'm going to reduce the cost 10%. We're talking about quantitative change, right? We can now do things very, very differently and so on. So that's the part. The other part about access that I wanted to talk about is not just access to space itself, but it's the fact that we're already seeing tremendous interest in cislunar. We talk a lot about low Earth orbit, mid-Earth orbit, and geostationary, so LEO, MEO, GEO. We're now seeing already a lot of interest in going beyond and cislunar, and so a little deeper into space. So that's maybe a geographical expansion. But also there is a political expansion, right? We are seeing, I like to tell my team that space is cool again, and that's just fantastic. There is private capital coming into space. There's a lot of interest in space that attracts, the most important thing. And now this conversation is the people, is the talent that attracts a new talent. So it's a renaissance in space that we're seeing. I think it's just eye-watering. It's a fantastic time to be in space. We're very fortunate to be here today. But there's also political expansion, right? Where in this kind of time frame, every country will either have their own assets or their own interest in space, even though they might have been manufactured, launched, and operated by partnership with another nation and so on.
We'll be right back. Indeed, yes, we're seeing things moving quickly in that direction. Yeah.
So we see that, and then finally we get to space, right? Which is, I think, what we're here to talk about. But I thought it was important to start on Earth, see how we get there, and then right, let's talk about protect, connect, and explore. So one of the missions we have today, right? Remote sensing, communications, exploration, so on. We see those continuing and expanding, no question about this. We also see new missions are going to develop, such as space traffic remediation, space traffic management, debris remediation, space tourism. We're already seeing some movements in that direction. So there's definitely some new missions that are gonna come. Now, for us really to accelerate this, and I got to tell you, NASA, I don't think NASA gets enough credit for everything NASA does, not only on the technology front, but also in maintaining, sustaining, and expanding our industrial base here. The whole business about commercialization of space and so on, NASA is, when you really dive 2-3 levels deeper, you see the NASA is behind enabling a lot of that, a lot of these new entrants, small or not, new companies and so on. So I wanted to acknowledge that. When you think about that, one of the key elements really to democratize space, to make it more accessible, right, is infrastructure. Well, what does that mean? What does that mean? Well, it means power. It means propulsion. It means communication. Mobility, if we're talking Moon and Mars, mobility. If every company that in the future that is going to go and has an idea to put a system or service in space, if they have to develop their own communication systems and their own power systems and so on and so forth, it does become the barrier for entry becomes significant. If those are in place and they can just tap into it, right? Then it's a whole different ballgame. Again, and go back to what do you focus on, your time, your energy, your resources. You focus on your mission and the unique aspects that you're bringing, that you're offering. So think about, I have an idea, I'm going to put a system in space, and you know what? I'm going to have a module here that, there is an infrastructure for power in space, and maybe we're doing nuclear power. We're power beaming. We're beaming power to these different assets in space. So my spacecraft will have a little, it receives power from that. So I don't see that, the nuclear and the power beaming as replacing solar arrays and things like that, but we see that as an augmentation for that. Similarly, for communication, we're already seeing constellations with thousands of spacecraft like Starlink. Within China also has plans to put thousands of spacecraft and so on. So we see that proliferation. So that's good, right? Because communication is a key element of infrastructure that we're going to need in space. So, but when we look at that, we assume that it's reliable and it's trustworthy. So if you can't count on that, then mission critical, like not only defense, but also banking systems and things like that run into information that goes through satellite constellations, you need to be able to trust that. So you also are going to need higher information content, higher bandwidth. Think about bits per photon, right? If we're talking about that. And what we foresee here, and now let me pull a little bit of the technology here. I already mentioned nuclear a little bit for nuclear power. Let me pull a little bit another one here, which is quantum communications. And people generally, and me too, when we talk about quantum communications, the first thing, it's unbreakable. It's super secure. It's unbreakable. It is true. Check that. That's being demonstrated around the world in many laboratories and this, that, and that's all fine. The quantum key distribution aspects and so on. But there is another aspect of quantum key, the quantum comms, that is not as well publicized, and that has to do with by exploring different protocols, by multiplexing in time, space, and frequency, we can truly increase information density and information content. And we actually have demonstrated that, not only at the laboratory. We did a field demonstration at our Denver facility here. We have a tabletop mountain range. We demonstrated that. Actually, a more stringent environment than in space, because you have to deal with the atmosphere. And we demonstrated, and we expect a 10x or higher order of magnitude in terms of information content. So these are the kind of technologies and capabilities that the Advanced Technology Center is working on and developing, because this really opens up a whole new capability, right? In this case, the element of infrastructure, secure, but also higher. And we're going to need it, right? Because we see the proliferation of these systems. Propulsion is another element that is very critical. We see NASA funding and enabling cryogenic storage of propellants in space and so on. We see that maybe on the shorter term, the next 10 years or so, very critical. But we really see on the long term nuclear propulsion being a key element, because it's not only low Earth orbit. We're talked about it's MEO, GEO, it's cislunar, right? It's across the board. It's also deep space. I was talking to you about OREX, OSIRIS-REx, and we built that system for NASA, exciting, and so on. Well, it did take us several years to go rendezvous with this asteroid, right? Collect the sample and come back. I think the rendezvous was maybe 2 years ago and so on, and that's all good. But as a species, humans, we need to accelerate our learning, right? And so how do we do that? So for some of these deep space missions, we can actually accelerate, because the majority of the mission time is just getting where you need to go. We talk about going to the icy moons of Jupiter and things like that. Well, with nuclear propulsion, we can start moving in that direction. And we talk about going to Mars, right? And so on. Again, nuclear propulsion will help us cut that transit time. So these are some of the key technology elements that we see. Let me talk about a different mission here. Let me talk about remote sensing. We do a lot of looking at the Earth and what's happening. Well, now I want to tie it back to what I talked to you in terms of what's happening on Earth, right? If you're really now producing this spacecraft on a cadence, you're getting them accessing on a cadence, we can now start thinking about, forgive me, I know some people are going to get offended, but disposable spacecraft. A spacecraft that maybe they only need to last a couple of years or so, right? And it's not because they're not going to work longer than that, but it's because you're developing new technology and so on, so we're refreshing that. And if you're talking about large constellations, not only for communications, but also for remote sensing and so on, you can think about a system that is resilient. And the resilience is in the architecture. It's not only on the platform per se, right? So if you have a network of spacecraft for communications, for remote sensing, and so on, and you lose one, you lose two, you lose 10, you lose 100. If it's a network, you're going to have a graceful degradation in terms of performance, and you're populating this back on a cadence. So it's a different way to think about this. There are some exciting technologies. Since the time of Galileo, I'm talking about remote sensing, right? Optical systems, we image on the focal plane, right? We collect light through a lens or a mirror. reflect on, secondary, tertiary mirrors and so on, and then focus that on a focal plane, and we get the image, and it works very well. We're going to continue to do that. That's how James Webb worked. That's how Hubble works, and all of that. Well, there is a different way to do an image. I like to call it the imaging computer, and that's interferometric imaging, where you measure, you create interferograms, you collect light, you interfere, you generate interferograms. And radio astronomers have been doing that for ages, right? Now, in radio astronomy, the wavelength is a little longer, so it's a little easier to do it in optics, right? You have these very, very small wavelengths, require very, very precise control of the wave of the path length of light, so that you can have the proper interferograms. But we've demonstrated that in the lab. We work with a number of universities. We actually showed that it works not only simulation, but actually in hardware. And the idea here is to bring image computing to a whole new level through interferometric imaging, where we have thousands of lenslets, not just two telescopes collecting light and interfering it. And you're now creating thousands of interferograms by combining light from these, different lenslets on this lenslet array, if you will, and you then can compute an image from that. Why would we want to do that? Well, there is a 10x reduction in volume and mass on the system. It's not simple, it's complex, but you're shifting the complexity to the fabrication phase of the program as opposed to the later stages of integration and testing phase. And that is done basically in a semiconductor factory, right? It's a solid state device. So that's interferometric imaging. And now it tied back that you're producing this solid state imagers, you're launching them on cadence, and you have a large network. We're going to be able to observe every square meter of Earth on a continuous basis. We're going to be able to track every object on Earth, and we're going to be able to track every object in space, and we need to do that. So that's a different vision for remote sensing.
It is a very comprehensive vision, and there is a lot involved there. So I'm sort of still digesting it a little bit, but it's very impressive. The thought that comes to mind, aside from the stuff that I was sort of geeking out on personally, because you mentioned a few things that I'm like, I'm really, really excited about nuclear propulsion, for example. So just hearing you mentioning that, I was like, yes, that's great. I'm thinking about people who are maybe beginning their careers right now and thinking, I want to help support making some component, several of these components happen. Obviously, these are fantastic visions, but people want to work towards making that happen, seeing that real. What should we tell people who are coming up through the workforce? How do we support the workforce now to help make Space 2050 happen?
Yeah, well, so what I'd like to tell them is come and join us, right? And when I say join us, this is beyond Lockheed. We started this piece, but there are many organizations, like NASA is fantastic. They always create a vision for the future and so on. And when you look at that, there's a lot of overlap, and other organizations do that too. When you think about a vision that is this broad and what we need to do to make it happen, this goes beyond any company or any organization. This is really, it's a call to the aerospace community, right, at large. So what I would tell them is it's an exciting time to join space, to be in space. There are many, many needs, right? Just this brief conversation here, we talked about nuclear power, talked about propulsion. We didn't even talk about in-orbit assembly, repair. We didn't even talk about habitats on the moon and the whole medical aspect of that. Because if we're going to have humans on moon and Mars and in deep space, right, we need to make sure that they're safe, they're protected. So there's a whole element here of the psychology, of the medical aspect, of the health aspect of that, right? We need DNA repair technology to deal with radiation, right? That's beyond my area of knowledge here. But it is very broad. And that's, I think, the message. It's broad. It will take all of us, right? It will take the community. So my call is a call to the community, to large and small companies, to space agencies at large. Let's get together because the challenges are significant. But the rewards are also eye-watering. And if we pull out together and we can push in a few of these key directions here, we're going to just accelerate the future.
Excellent. Well, that's I'm sure people will hear that loud and clear. So I know you're going to be at Ascend, and there's a lot planned for that. Could you just give me a quick update on sort of what is planned for Ascend?
We're very excited by Ascend. We, at Lockheed, we have had this strategic partnership with AIAA for decades. We cherish that very much. And because, as I mentioned to you, this vision for the future is really a vision for the aerospace community at large. It's not any single company or any single organization, so on. I was delighted when we held an event and we rolled out the Space 2050 vision in last year in Washington, D.C., when an event in AIAA. Dan Dumbacher, the executive director, was there with his team. And we actually started the conversation right away. Dan and his team saw the value, and I saw immediately the value of having an AIAA kind of, which is an international organization with a tremendous footprint, tremendous respect, carry the baton, right, for industry and bring us all together as a community, right? So in a sense, it's really the culmination of that. We've been working closely with the AIAA. Of course, we're going to have plenary talks. We're going to have a number of panels that touch on many of the aspects that we talked here on the past few minutes. But we actually went beyond that, and that's what I'm so excited about. There are over 35 technical papers distributed at, I think, 8 different technical sessions with representation from industry at large, startups, large companies, space agencies, NASA, and others. And it's really the first major step in bringing the community together towards that, right? So I'm super excited about Ascend, and I hope all of our listeners here can join us today. It's going to be super exciting.
That's it for T-Minus Deep Space for October 21st, 2023. Join us at Ascend, October 23rd through 25th, to hear more about Space 2050. We'd love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures that we deliver the information that keeps you a step ahead in the rapidly changing space industry. This episode was produced by Alice Carruth, mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Brandon Karp. Our chief information officer is Eric Tillman. And I'm Maria Varmazis. Thanks for listening.